Hello students. In the previous lecture we come to know about the MTI radar, what MTI radar stands for and what it is. And I have also told you about the range, how the range is being calculated. Now moving onwards, we come to know that how the drift frequency, which is to be calculated just to know the motion of an object. So here I have written a formula where Fd is having relationship with the radial velocity. This radial velocity Vr is the velocity of an object which is moving. This Fd is a Doppler frequency. So what happens in the receiver section of MTI radar, there is a DLC circuit, that stands for delay line canceller, which identifies this Fd. What we have to know, because if once we come to know about this Fd, we will able to calculate this Pr, this velocity of an object. So first of all we have to know about this Fd, that how we come to know about the value of this Fd. And this Fd stands for Doppler's frequency or drift frequency of that moving target. Let us see the radar system by which graphically it is being explained. The graph which is plotted between two parameters, that is in between time and amplitude. Here first of all this black one, the black one represents the graph or the peak from the fixed object which is in the natural environment or any type of fixed object. The graph, the peaks are coming from that objects. Now what happens, a target is moving with such an speed that we later on come to know that moving target, that target is moving in vicinity in where these peaks are received at the receiver. And when the object comes in this vicinity, what happens, a new graph is added in between these peaks of the graph. So what this actually means, this is nothing but the signal which is added when there is some moving target. Means in this vicinity where these graphs are being shown, a new object is moved, and by that this graph is plotted. So what happens, if we have to know or understand graphically, what we do by using this DLC, delay line canceller, we, in the second case when this graph is shown including this red part, we take this as a second and we subtract this second graph with that of initial graph, which when black peaks were shown. What we have only this part, and if we are able to calculate or know about this reddish part, we come to know what the actually frequency of this moving object, because when we subtract the whole graph with that of initial graph, we have only this part. So by having this part, we are able to calculate the drift frequency, and once this drift frequency is calculated, the velocity of an object is being calculated. Here what we have written, F1, F2, F3, these are related to these fixed objects. Means F1 is something fixed object, the peak is coming from that object, this peak was also coming from that object, F3 is also peak coming from that object. But this reddish part is the graph which of an object when it comes in that vicinity. So moving onwards, we will come to know what DLC actually do. This is the frequency response of delay line canceller. This is the block diagram of that delay. Mathematically I will let you know in some other video, but here we come to know that this actually the frequency response of this DLC circuit used in the MTI receiver section. This frequency response is plotted in between amplitude and frequency. Here I have marked location 1, 2, 3 and 4. This location is nothing but the positions where frequency response of that object is 0, and with these locations 1, 2, 3, 4, the object associated with these locations, that is the frequency response of that object, if is associated with these positions, the associate the speed associated with these positions will called blind speed. That means what blind speed is, that means if the object is moving with such a speed that its frequency response is located at some position 1, 2, 3 and 4, that speed is called blind speed. So if we are unable to track that target which is moving in such a blind speed, we switch for the multiple DLCs, that is 2 DLCs or 3 DLCs, whatever may be used, just which I have drawn here. Here what happens, the frequency response is shown. This is for the first DLC and this is for the second DLC. What happens when we cascade these 2 DLCs and used in our receiver section in MTI radar, such net response is shown like this red part. And what happens, there will be never any blind speed situations will arise, or any positions will be marked where the frequency response of that receiver will be 0. So just by avoiding frequency response to be 0, we will also able to avoid that blind speed. And what we have written in it, so to avoid this blind speed, which uses multiple DLCs. This is all about the MTI radar, and about the DLC and few discussion about the blind speed I will put in the next video. Thank you.